Butanene reacts with a reagent in the form of HY, there's no such thing as Y, to form a saturated compound, so with single bonds. Suggests a reagent in the form of HY that could react with butanene. So the double bond of butanene will react with something like hydrogen bromide, HBr. Draw a mechanism. Well, it's going to be electrophilic and it's going to be addition because this will add across the double bond. And what will actually happen is the mechanism will look like that. The double bond will actually attack the H. That's not a very good drawing. That double bond, the electrons will bond to the H and the Br will break off. Now where's the H go? It goes to the left-hand carbon, the carbon that's got the most hydrogens on. So that carbon's got 2 hydrogens, that carbon's only got 1. So it joins the carbon already with 2 hydrogens with the most number of hydrogens. So there it is, it's joined that to make a CH3 instead of a CH2. Now this carbon hasn't got enough bonds, so that forms a carbonium ion, a C+ ion. It's a secondary carbonium ion because it's got 2 other carbons bonded to the C+. Secondary carbonium ion is more stable than a primary carbonium ion, and we'll talk about that in a minute. So the Br has had minuses. It's got a minus, it's got a lone pair of electrons. The pair of electrons from the bond has gone onto the Br, and then that will attack the secondary carbonium ion here and form this compound here, which is going to be butane. It's going to be 2-bromobutane. Explain how 3 isomeric products are formed when HY reacts with butanene. Well, this is the major product where the H bonds to the C with most H's and forms the more stable secondary carbonium ion. However, the H could bond to this one and form a plus here, so the plus could be on this carbon instead, and this could have 2 H's, so the H could bond to this one and leave this one as CH2 with a plus, and the Br could join onto that, and it would create 1-bromobutane, so it could end up as a position isomer of this. But it's less likely to do so. It's a minor product, so it will do it to some extent, but not very much, not as much, because that primary carbonium ion will be less stable than the secondary carbonium ion. Where's the third product going to come from? Well, we've made a chiral carbon here, so these are going to have enantiomers, so this is going to be optically active because that carbon has got 4 different groups attached. So that's your answer. The major product here exists as a pair of enantiomers, and the third one is 1-bromobutane because it's obtained by a minor product when a primary carbocation is formed instead of the secondary carbocation, which is more stable.